I want to solve a couple more equations, three of them in fact, where kind of weird things happen, at least in the first two. So if I want to solve this equation, I need to simplify. I've got 3x minus 7. Let's do a little distributive property over here. That'll give me 3x plus 3. Now I want my numbers together, my constants and my variables together. So why don't I move my variables? So I'm going to subtract 3x from both sides. So red for subtraction. Equals 3x plus 3, and then minus 3x. Okay, 3x minus 7 minus 3x is minus 7, negative 7. Great. 3x plus 3 minus 3x is 3, positive 3. All right. Now I have a problem. My problem is that there are no numbers I can think of to put into this equation right here to make negative 7 equal 3. In fact, I don't even have any variables left to put in there to try to make negative 7 equal 3. Remember, though, since we used the addition property of equality to get from here to there, these two equations are equivalent. That means they have the same solution set. That means that anything that'll make this bottom one true will make that top one true, and nothing does that. So this equation, both of these equations, in fact have no solutions. And if I wanted the solution set, so the solution set is the set without anything in it, or the empty set. Okay? This equation has no solutions because it's equivalent to an equation that definitely has no solutions. Obviously has no solutions. Nothing I pick is going to make negative 7 equal 3. Okay, let's do another one. This must be another kooky one, so let's see what happens. Looks like I need to distribute. So this is 2 times x is 2x. I'll be writing in black, thank you. 2 times x is 2x, 2 times 4 is 8. This equals 4x plus 5 minus 2x plus 3. Okay, this side is good, 2x plus 8. This side over here, let's see, I've got a 4x, here's a minus 2x. 4x minus 2x is 2x. Then here's a plus 5. Here's a plus 3. 5 plus 3 is plus 8. Okay, now I wish my variables were on the same side of the equation. So why don't I subtract 2x from both sides? If you see where we're going, you could stop now because those two sides are exactly the same as each other. But I'll keep going just in case I didn't notice that. So 2x plus 8 minus 2x gives me 8. 2x plus 8 minus 2x gives me 8. And here I have something different happening. Unlike my last one that was a problem, this is in fact not a problem. I can think of all kinds of numbers that will guarantee that 8 equal 8. In fact, all of them do. So here, all, and we'll stick to real numbers are solutions. Right? Because anything I pick is going to make this equation true, because it's already true. And, since that one's equivalent to this one, anything I pick will make this equation true, because it's already true. So, all real numbers are solutions. If I want the solution set, we'll typically use set builder notation, because when I've got a bunch of answers to equations, that's kind of the way to go. So the set of all x, such that x is an element of the real numbers, is one way to write it. Just the real numbers would be another way to write it. You can write out the real numbers in words if you don't remember that symbol. So the set of all x, such that x is a real number. Okay, either way here, anything I pick is going to be a solution. So all real numbers or that written as a set. Okay, This last one is trickier than the other two because now that you know about the other two, you're going to want to use that hammer that I just handed you to hammer every problem that looks weird. This one, in fact, isn't weird. So let's see. I've got 15 plus 6x equals, need to distribute over here, distribute. 3 times 5 is 15. 3 times 9x is 27x minus 4x. Okay, can't do anything else over here. 15 plus 6x equals, over here I've got a 15, so I'll keep him. And then I've got a plus 27x, a minus 4x. 27 minus 4 is 23, so plus 23x. Now I want my variables together. I like the coefficient to be positive, so I'm going to move this 6x to the other side. So minus 6x. This equals 15 plus 23x minus 6x. 15 plus 6x minus 6x is 15. 15 plus 23 minus 6x is 15 plus 17x. Okay. Now, I want my numbers together. So I want to get rid of this 15, so I'll subtract 15 from both sides. So 15 minus 15 equals 15 plus 17x minus 15. 15 minus 15 is 0. Sweet. 15 plus 17x minus 15 is 17x. Okay. Now I'm down to that case where I've got one thing equals one thing. I'm ready to divide to get my coefficient on my number equal to 1. So I want to get this 17x down to just x. So I'll divide by 17. Divide by 17. 0 divided by 17. If I take 0 and put it in 17 parts, I'll get 0. 17 times x divided by 17 is x. So 0 is the solution to this equation, right? If I put 0 in here, I get something that's true. In fact, if I put 0 in here, I get a true equation. If I put 0 in any of these equivalent equations, I'll get a true equation. And just to check, if we go back to our original equation and put in 0, well, that's pretty easy to do. 0 here will make this go away, because 6 times 0 is 0. 0 here will make this go away, because 9 times 0 is 0. 0 here will make this go away, because 4 times 0 is 0. 15 equals 3 times 5? Yeah. 0 is my solution to that equation, because when I put it in, I get a true equation. So 0 is the solution. The reason that I brought this up in this video is it's easy to look at, especially roundabout here or here, and decide that there's something wrong when in fact there isn't. It just happens to be that x is 0. Unlike these other guys where I had weird things and then I ended up with all real numbers or no solutions because I had a problem. That last problem is different because x is a number, x can be 0. If x is 0, all these equations are true.